We saw basic texturing through fixed function pipeline. So we use vertex arrays for the fixed function pipeline, and we saw how texturing generally happened. We did not use any lighting component, so we had kind of vertices and then texture coordinates, and through fixed function pipelining with default texture unit 0, we could draw a texture. So that we saw. And for the texturing, we used complex models that is generated through Blender, and through that we did the texture. Then same texture through vertex array. Now vertex array is converted into vertex array object, and inside the vertex array the components like vertex or texture coordinate, or it can be normal. So they are getting converted to BBUs, vertex buffer object. So the vertex array objects and its components, they are getting converted to VAO and BBU in GPU. So we have now kind of ready-made routine to compile them. So we from the fixed function pipeline to we proceeded towards VAO, towards shaders. So very basic shaders, fragment shader and vertex shader and fragment shader we used. We used sampler as for the texture unit 0. And then we have a kind of a new library where we have very easy to compile the code for the shaders code and generation of VAO and VB. So through that through shaders we kind of drew the model and placed textures on top of it, and we did transformation. So this is what we saw. Now we will see lighting. So in the slides we show kind of a secondary color. So in secondary color, the new thing that comes in is called a specular component. So whatever we provided now, the texturing, it is also called diffusing. Means if I see the lighting has many components: ambience, diffuse, specular means shining. So basic texturing is diffuse, means the color of the model that we think of and that we change. So basic texture is diffusing. So diffusing we already saw. So what remaining is in lighting. So light the vertices, it modifies vertices component from kind of it does coloring to the vertices component, and based upon the ambience, diffuse and specular. So ambience little bit we'll see kind of a hinting kind of ambience, but not kind of very professional way. And mainly we'll see the specular. So shining. So anyway we have a diffuse component we have already brought. So shining, that we'll see now in the kind of lighting calculation. So what is shining? Means a diffuse, whatever we have drawn for the diffuse, we can modify diffuse for the lighting in the sense that if the model is behind, the part of the model is behind, then in lighting component its diffuse color should be less. Means since the normal of the particular vertices and light normal, light vector and a normal vector from the particular vertex, if they are not aligned, then its diffuse also should little bit less. I won't say fade, but it should be little bit less. So in diffuse part also, as per the lighting, as per the normal changes, we'll see that diffuse will little bit it will change. And specular. So in specular, we have kind of the eye direction where eye is fit, and then where is the light. So we'll use the light reflection component and eye component. So if I see the diffuse, then up to 90 degree from the center. So where we see the normal from the eye or from the camera on the model, from there 90 degree left and 90 degree right. So 180 degree generally we draw the diffuse component, lighter brightness can change. But for the specular component, up till some point we can draw, beyond that we cannot draw. Means the what normals we'll use, and if we use the dot means cos, then it will it will go negative. So we will focus only few parts, maybe left 30 degree and right 30 degree, and then we'll see the shininess. So shininess would it will reduce it even more, but it will give a specular component. So that will. Okay, so we'll see now. So in the lab session, design texture object. Okay, so multi-texturing texture function, specular lighting. So this is what we'll see now. So in the designing, we have done kind of a new thing that anyway we have demonstrated. Okay, so in the util-C, we have added a few functions. So util-C being a kind of a class, then few functions added like compile shader. So it would compile the shaders, list of shaders, create a VAO. So it will create a VAO, vertex array object. It would create a list of vertex array. Okay, and if we have compiled shader, then based upon a shader, we have two attributes. One is uniform and another is. So there are two data types. One is mainly from that we can insert from the outside. One is uniform and one is attribute. So what is location there? So get unilog. So get uniform location and get attribute location. So these functions we have added. Now if we see the GPU that we have already talked in the shaders. So like CPU has RAM and it has a cache and then it has control and ALU. But if you see the GPU, it is a kind of bunch of ALU only. So it is specialized in mathematical arithmetic logic unit. So mathematics work it is specialized in, and it has control cache. So in the cache, the control cache, so we can have many VAO in the control cache. Each VAO has many VBO. VBO can be of type GL array buffer or GL array buffer and GL element. This is for indexing. So we can have set of VAOs there. So that is the idea. Now we will see this lighting model. So it's a bit complex. So this is what the idea is. So that will proceed. Okay, so we will modify our shader code first and then we'll proceed with. Okay, so we have this code and this is what shader code we have written. So this idea is that we will modify it. So shader code is uniform view sphere. So we will have uniform transpose inverse. So when we talk about transpose inverse, so we are targeting to normal vectors. So it is pretty clear. So there is some normal and then we have normal. Now since lighting comes, then there is normal. We have GL position. Now vertex coordinate. So two things we'll add here. Vertex coordinate equal to, so model view sphere multiplied by vec4 and that is code. So whatever is transformed now, so that we will add, and here we will do norm Okay, so varying, we have so many varying now. So varying 3 and 3 and vertex chord, vertex normal, and vertex chord is model view sphere. So whatever the coordinate is, so after transformation what would be the new, and here it is normal. So normal is a kind of a vector, so we'll go with transpose inverse, transpose inverse. Okay, so we are done with the vertex shader, and then now we'll continue with the, now we will have a kind of grouping. So I would say struct material. Material itself, it would become kind of uniform, so not required. And if for material there are other attributes. So one is vec3. Okay, so we have learned from Python, so we'll make indentation specular and float shininess, struct light, and here we have vec4 position, vec3 ambient. Okay, so little bit ambient will add, and vec3 specular, vec3 diffuse, and we will end. Okay, so we have these many varyings, so 3 varyings, so 3 varying. Okay, now whatever great thing we have done for the, that we will declare. So we will have uniform mat 4 and model view light. So light source would be kind of transforming, it would change uniform material uniform light being light. So we have done this much. Okay, so what is the view position? Okay, so now we will first we'll add, I believe, specular, then slowly we'll add, or we'll add together. If we want a specular addition only, then we don't need this diffuse. We will add diffuse, not a specular right now. Okay, so specular we will comment it, otherwise it will do other nonsense, and only will use add diffuse and ambient. Okay, now we have a model view light, so light is changing, and here, so frag color, that will change. So here we have, so view pos is not required now, so we'll move towards vectors. So we have vector 3, n and l. So normal, n is, I think it's not mentioned anyway. Okay, so what we are going to do now? Okay, so if I have a surface like this, so what we can do for this surface? So this is a surface. Now at any point, I am taking this as a point, at any point. Okay, how much lighting it would receive? Means we are now in lighting. So how much lighting it would receive? Okay, so this is a kind of light normal. So this is a vertex, or since vertex is here, so I believe this is perfect. So this is vertex normal. So we call it okay, so we call it N. Okay, and this is transform coordinate, means when we have done all the transformation. Okay, not at the beginning. And now we have our light is placed here. Okay, so the vector that is connecting here to the light is light vector. Okay, and its name is light. Okay, so normal vector, light vector, how much light it will receive? So that is completely based upon this angle. This angle. If this angle is more, then light it would receive is less. So this is N and L. Okay, so we will see that. So N and L, now we'll calculate N the way we said. So it is nothing but normalize vertex coordinate, normalize normal. And what is L? So L is normalize model view light into light dot position XYZ minus vertex chord. Okay, pretty simple. So this line L is vertex position, light position minus vertex position. So this is light position. Light dot position. Okay, so this is light dot position. Now this is vertex position, so I would say chord, vertex chord, because it is transformed. So vertex light position minus vertex chord gives this L. Okay, vector, and this is normal anyway we get through Blender. So this is transformed one. So normal vertex normally transformed one, and we are transforming the light position, and so model view into light position. That would be more perfect. Model view light into light position. So this is actually this location is, and now we have N and L. So we'll proceed. So what is frac color now? Oh, frac color is already there. So we will kind of modify it. So I will say light dot ambient, and then texture diffuse. Now it is material diffuse, material dot diffuse, vertex text code dot RGB. Okay, so this is, and then okay, so we will kind of do this. Is ambient we have calculated, diffuse we are calculating now. So diffuse will be light dot diffuse multiplied by max 0.0 dot, this is what we are looking, L dot N multiplied by texture. So I don't know how far we have done it correctly. So this is this, this is this. Okay, so I believe we are right. Okay, so whatever the light ambient is, and texture material dot diffuse, vertex text coordinate, and RGB. Okay, and then light dot diffuse dot L and N. Okay, only bright side. If it is going negative means opposite side, so 0. And then material dot diffuse. So diffuse component we have, I think we are done. Yes, it is not very difficult. Okay, so we have light position, we are dependent upon light ambient, light diffuse. That's it. Now we will fill it down the line. We have filled it. Okay, so for diffuse we have already filled it. Now we will fill for others. Okay, so what are others? Light dot position. Okay, so what is the value? We can set light position something like 0, 0 and 5. This is the beginning position. Okay, not the transformed position. Now we will add ambient, and light ambient is 0, 0. Okay, so it is only 3, so 0.2. And we will add light diffuse, and we will set it really big, or we can just say 1, 1, 1. This would be enough. Okay, so nice. Means if I have library, we have introduced compile shader, create VAO, and get unilock and attrib lock. Means it is cakewalk now. Just get unilock and these positions and done. Now these are kind of local code, not global code. Okay, so now we will move towards, so we will have a lighting. Okay, so what we did is a projection we placed, and then this is for model view. Now same we will do for lighting. So I think I can safely remove this global. Okay, so for lighting we will have a push matrix, okay, and GL pop matrix. Okay, in this legacy I'll just keep it. Okay, push matrix and pop matrix, and lighting will have its own translation. So we'll say, instead of a sphere, I will say kind of light source, and then okay, whatever the model view matrix that is transformed, so that will say light. So get Unilog shader program model view light and just set it. Done. And pop matrix. So lighting is done. GL push matrix. And whatever we have done. So we have another one, that is transpose inverse. Transpose inverse model view. And here I have to fill the grid sentiments for the transpose. So NP transpose and NP lin ALG dot invert, and 2 we will place here. So transpose and inverse of the model view matrix. Okay, so this much we have done. Then followed by we will activate a texture, and then we will actually do the needful, and we should do GL pop matrix here itself rather than doing here. It will be confusing. Okay, so we'll remove this code. So global transformation, it is, we have seen global transformation, so it's all right. So now we have a push matrix and a light. We have done translation as per the light source, and model view light matrix we have set as per the model view matrix, and now we have push matrix again, and we have done a transformation model view sphere and inverse model view sphere, and then we have drawn the texture, and then global pop matrix. So this is a pop matrix, push matrix, pop matrix, push matrix in -10. So in the transformation, so these are local code. Okay, so light source and beginning is light source. So it starts with the light source. Then so light source should start moving, and we have placed diffuse, light position, light ambient and light diffuse. Okay, I mean we can try it. There is no harm in trying. Okay, so Mr. Semicolon is everywhere. I'll check diffuse if anything is. Okay, so material diffuse and light diffuse, and this is material dot diffuse and light diffuse. So many, too many parameters to wait for. So in fragment shader we are getting, and that is line number 26. Line number 20. Okay, so GL frag color vector 4. Light ambience into texture dot RGB plus, okay, diffuse color maximum, and okay, so whatever we have achieved, let's try again. Okay, so vertex and fragment shader are through. Okay, invalid location it is showing. So coordinate, texture, material, diffuse, material, light position, GL uniform light position. Okay, GL get uni lock. Okay, so this is a kind of type is we are messing up. So I would say 3F not vector. So there is some problem with vector. So 3F and Mr. 4F. Okay, so light position is 4, whereas others are 3. We'll try again. Okay, actually it is drawing, but it is very highly fed. There should not be any negative. So 2, 1, 3, 0, 7, 6, 5, 4, 2, 0. So it's completely all right. Okay, so we have not added the normal, but we are doing the calculation with the normal. So normal will do. Okay, so we have already discussed that whatever the object file we are receiving, so per vertex there are 8 data, 3 are for coordinate, 3 for normal and 2 for text coordinate. So coordinate starts from 0 and 3 is the length. Normal starts from 3 and 3 is the length. Text code starts from 6 and length is 2. So this buffer we get, and when we create a VAO, at that time we set the attribute. So there is no shame in showing VAO. So OpenGL util create VAO. While creating the VAO, we can clearly see that we are setting the buffer and vertex GL enable. So whatever attribute location we are getting, that we are enabling, and attribute pointer, so whatever is the location, on that we are pushing the data. Okay, so we'll try again. Oh, we get it. So this is the kind of earth, and if I rotate, it would rotate the light source as per the calculus. It is rotating the light source. Okay, I can bring it near. Okay, but light source is kept at one location. So maximum this much we can do, and we are rotating. We can rotate the light source. Light source can be rotated in x direction also. Okay, so this is, if we want kind of more lighting, I think it's okay. Means we'll see later. And Earth will be big, but okay. So it crossed the light source position, and it is toward the camera, but light source enters. You see the positional light source, so it entered inside the camera. So that is inside the sphere. So if we do far, then it will. Okay, one solution to show it big is GLU perspective. We are showing. We reduce the angle to 20. Okay, it is really big. This is what we are. So I can rotate the light. And I can really rotate the earth where light source is fixed, or I can rotate the light source on right side, then rotate the earth. Okay, we can have. So I think it's not a bad idea to add a light source object So light source, we don't know where the light source is. So we can add that in reality. So for that, I think we have to write code for that. Okay, so I think we can do copy paste. We have done light sourcing in lighting tutorial. So if I see that, then we have light source. So there is no harm in copy pasting that light source. Okay, so these are light source, vertex shader and fragment shader. Okay, so now we have two shaders, one vertex fragment and another again okay, so vert code 2 and vert frag code 2, and here we don't need a different thing because now we are smart in compiling it. Okay, so color 2 stuff we will remove. Now it has code only. I can just search for 2. Okay, so version is 330 we are using now. Okay, so vertex color we can just say vec 4. So it is white and we can remove this. Okay, so model view light and coordinate pointer. Now we will place it. So we'll compile it. So okay, so in compile shader we can add one more. So this is how it is designed, and I'll say vert source 2 and frag source 2. Okay, idea is that we have to pass kind of in a tuple. So vert code source 2 frag vert source 2 and frag source 2. So this is the tuple. Okay, compile. That's it. Now shader program is an array now. Okay, likewise, so whatever we did, we have to place in a tuple. Now this will come in a tuple. Okay, so we have another tuple now. So init dot shader program 1 mat 2. So that will add. Again it is of 8 only, and it only has code that is 0 to 3. Okay, now our VO is created in one go. No need to write too many things. So we will see where are we. Okay, done. So now we are kind of we have placed it. Okay, now we will kind of add the code for drawing it. So now everywhere it will become shader program 0, because we have 0 and 1, and VAO also it will be 0. Okay, and here what we were doing, shader program 0, Okay, that's it. Now we did for the something with VAO. So now it is VAO 0 because there are two VAO now. One is for okay. Now we will draw it. So in the display, okay. So we will draw it. So we will add a kind of a parameter here called Q. Set attr in the init will say cube and it is 0. So at the beginning it won't show. So that is the idea. And I believe we can copy paste that code. If cube. So we already have this code. Cube. So what we have written in the lighting tutorial. So this is for Q. Okay, so we will use, if that is the case, then shader program 1, push matrix, and then transformation for the Q. So it will follow the transformation of the light source only and translate 5. So rather than placing two places, I can just say light position. We will initialize and then model to lock. So instead of lock, it is now util I get unilock and then init shader program 1, and what we want is model view light. Okay, so model view light, that location we are getting. Okay, and that we are setting from here. Okay, so okay, so we are not doing any transformation. Whatever is done in the light source, we are enabling it. Okay, we have done a fixed translation of 5 so that it would match the light source, and then we are getting the model view light from there. Okay, so model view light we are setting it. Okay, and then we are binding to VAO1 and we are drawing triangles as per mat2 and popping the matrix. I believe it's okay. Okay, what is Mr. mat2? So init Q, now we will add here in the keyboard. So keyboard we will have something like if re search C or C in the key dot decode. If that is the case, then okay, so init dot Q we will set to equal to 1 if key equal to C, else it is 0. Okay, so if key dot decode means we are converting it to in string, and if that is C or capital C, then init dot cube is 1 base if it is small c, otherwise 0. Now we will see mat equal to mat. Okay, so we have mat2 now, and it follows cube. Okay, so kind of cube 0.1 means it is a small cube, so 0.1 dot option. and that's it. So here init mat, so it is init mat 2. We'll copy the cube, so copy okay. So we'll copy it here only, cube 0.1 dot out. Okay, so we have so many objects now. Cube 0, so I think we are all right. We have created for it, and then in the if it is init cube, then use 1, GL use program 1, push matrix, translate light position will add. So here also we will not use hard coded light position, and we will use light position. Light. This Python is amazing. We can just insert like this. Okay, so light position will have a global, and we'll say light position equal to 005. Okay, so now we have light position. I think we are done. Okay, so we have substitute VERTC word source 2 and flag source 2. Word source 2 is not defined. Okay, so instead of code it is source and similar. Okay, so do we have light? Okay, so light should appear. It's not appearing. RE is not defined. Import RE. So Mr. Cube is coming. Still not coming. Okay, so tuple out of range. Model view light. What we have done? 137. So Mr. Light source is coming, still not coming. Light is rotating, but light source is not. Okay, for the light source code and model view light is perfect, nothing is negative, so it should come. Okay, so we'll see the file again. Okay, so probably we have not added the projection, so we'll add the projection. So in the code, like we in the display def display, we have the projection set for one shader. So for this shader also we'll add the projection. Okay, so shader program 1, projection, that's it. So whatever the projection is, that will set in model view light. So we'll try again. light comes. Okay, so if I rotate light, light is rotating. Okay, so I can move up the light, move down, move right. Okay. Okay, to make it more shining, so we'll do some kind of alteration. Then we'll use a specular component. So now here when we set the, so we'll make it more diffuse. We have set 111, so we'll make it more so that it would be really shining. And GLU perspective will set some 30, so it should be okay. This is really lighting, and light source is moving. Okay, so it is moving in X direction also. Okay, if I press capital C, it should go away. So that is the idea. Okay, it doesn't have shining, so shining is a big thing. Means it should shine. So we'll add shining. So we have everything for shining. Specular, shine, and here specular. So that we need to add. Then we'll add there. So material dot. Okay, so here we will add. So others. So now we have material diffuse. So we'll add material specular. Specular, and a specular is 0.5, 0.5, 0.5. Okay, now we will use shininess. And shininess would be 20. I mean, this is what I think is better. 20. And here we will make it as 1i perfect. This will be 3f. Okay, and light position. So shininess will add, specular will add, specular against the light, and it would be 111. Okay, so light specular is ready, and material specular is ready, and shininess is ready. So it's ready. Now when we, so here we calculated the kind of, so when we see this, so up till it comes to kind of 180 degree, the way we are talking, suppose at 180 degree the vertex normal is like this, completely like this. Okay, and at this point if it is like this, then okay, this is, it is not very perfect, but this would be around 90 degree. Okay, so it won't be shown. Now we are talking about shininess. So shininess should show up to this region only. Okay, if I talk about shininess, then shininess should come up till here, not below that. So what is the kind of concept behind the shininess? So there is something called I. Now all these are in I coordinate, so they are transformed. So if my camera is kind of, it is placed here, Okay, so this is camera, and camera is placed at origin. This is where 0, 0, 0. Suppose I is here only. Okay, if I is here, and then if I talk about any vertex, so this is any vertex. Okay, what would be its shininess? So if this is the I and this is the light, so light will have reflection. So if this is the light, then light comes, okay, at this point, and then it gets reflected as per the normal at this point. So this is the normal. As per the normal, it's get reflected. Okay, so this is R. This is new thing. I would rather say minus R. Why it is minus? Okay, so L is in this direction. L is in this direction. If L is in this direction, then its reflection, if L is in this direction, then it will reflect in this direction. This is what we want. But if L is in this direction, opposite, reflection will be inwards. But we want outwards, so it will be minus R. So now this is minus R, and if this is I would say, now we'll draw the vert. So this is another vertex. This is another normal. This is another vector. And if this is I vector, if I call it, if this is I vector, then between I and minus R, whatever the angle is, that is the specular. Okay, right now only angle comes to 90 degree. If you see clearly, then this angle is coming to around 90 degree. Okay, so beyond that it cannot go. So what we are saying is that if we are calculating diffuse component, then diffuse component, it goes up till 180 degree, means 90 both sides. But if we are calculating the specular, then it won't go much. Okay, so specular, it won't go much. So because it depends upon the kind of I, so it won't go much. Whereas diffuse will go up to 90, but it won't go much. Specular, whatever. Now we have to calculate I and E and R. So that is the idea. And then when finish, shininess. Okay. Reflect L and N in minus direction, and E is normalize, and whatever the light position is, so light position is vec 3 0 0 0. This is fixed. We are not adding any kind of any model view transformation. And then vertex chord. Okay, so E is light position, and so I think we can save it. So green color was kind of Okay, so it was kind of diffuse. Okay, so we can really save it. Okay. Okay, so we will save kind of okay, so maximum we have 8, I believe. So 8.3. Okay. Okay, so we can add it here. It is 9.5. So we'll add it to texture 9.6. Okay, so we can add it as a post. Okay, so we have it. Now we will fill it. So we calculated NR, reflection and E. Now, so we have ambient component, and now we will add a specular component. So that is the idea. So light dot specular multiplied by power of max 0.0 dot E comma R material dot shininess material dot specular. Done. So finally we added the specular. So light specular multiplied by power of max dot E dot R material dot shininess and then material dot specular. So we are done. So this component we added. Now we are expecting shininess because we have done everything. Shader programming is not compiled. Okay, R undeclared. So we'll declare N, L, R and E. So R and okay, so fine, and then light dot specular power. Okay, material dot specular. Still it is making us wait. Oh, it is compiled, and then okay, material shininess. It is causing problem. GL uniform 1I103. Okay, so uniform 1i is 0 and then 0.5 is material specular. Material dot shininess is 20. GL uniform 1i utilize get unilog init shader 0. And it is 20. So we have not set it as float. This is what I believe. It is set as float. Okay, so probably shininess should be either it should be integer or here shininess 1 place, 2 place, 3 place. Okay. So we'll make it float. I think integer we could have changed their integer. Let's try. Oh, we are getting the shininess. Okay. So if I rotate the light, then shininess is also rotating. So white color is there. So shininess is visible. So this is shininess. White color shining we are seeing. Okay, so this is shining. This is shining. Okay, so we can increase it. So GLU perspective, I can make it kind of 1 to 40, and here at the beginning only in the display we can set it to minus 20, so that light we can light position we can make it 10. So now we will have some. Okay, so now we'll change the angle GLU perspective to kind of 20. Okay, now I can bring the light really near. Okay, so this is light, so I can remove the light. Okay, now I can bring it near. Okay, so this is bigger and I can rotate. So shininess is visible. It is white color spot. What you see, it's really looking. It's like it is shining. Okay, and we can rotate like this and then in this fashion. Okay, we can bring it little near. Okay, so we can change the Earth, Mr. Earth. So we have few images, or we can have in the aeroplane. So how shining works. So sphere we will have airplane, and then we have PNG. So Earth PNG we have like airplane.png, and we'll try. Okay, very nice. So lighting is there. Okay, so this is lighting. I can bring it near. and then we can just remove it and we can really rotate it. Wow! So it is really shining. So if it is not shining, then it is yellow. The back side we can see. If it is shining, then it is coming to white. Okay. Wow. So it is really shining. Means front also we can see. Okay, so we can bring uh, a kind of whale, and we'll replace whale shark here. So instead of airplane, I'll say whale shark. What is concept of whale shark now? Wow! So this is the whale shark. It is really shining. We can see the difference. So this is back side white and front side. Okay. Okay, so we can kind of placing it far so that we can see when it comes in. Okay, now we can bring it near. Okay, so left side it is shining. Now I can see the cube and I can rotate it. Wow. Okay, so camera is a little front, so I can kind of, okay, it's fine. Now I can rotate in this X direction also. Light went down. Too much shining, I would say. Okay, this is without shining. Okay, I can bring another earth. I think then we'll kind of call up. Okay, so we have satellite. So we can use, now it is GPU, so I believe everything is all right. Earth.jpg. Now PNG image, airplane.png. Now we have Earth JPEG, and in the opt file, whale shark. Now we have sphere. We'll try again. Okay, shining actually works better here. This is shimmering effect. What we are seeing is shimmering effect. So that will reduce. So light will kind of will bring little far, so that now we can rotate the light. Okay, so light came before the kind of in that direction. Okay, so I can rotate y direction. This is Pacific Ocean. Okay, so I think we are kind of done. Okay, so quickly I'll show the code again, and then we'll bring this map and we'll close it. So what we have done. Okay, so we have vertex code, and here we have kind of a transform coordinate and normal, and text coordinate we are passing as it is. And we have a material diffuse specular shininess like that we have for light. And we are calculating a normal vector as vertex normal and light vector as minus position. So light position to vertex coordinate. So that is the light. Reflection is minus reflect, and it is 0, 0, 0 and vertex coordinate. And then we are calculating the ambience. Okay. And then specular, and then diffuse component we are calculating. Okay, we have two second shader for Q. Okay, so here we have a texture object, so I would rather do like this. So texture object, and followed by we create a few two vertices, and then we compile the shader, create from the vertices we create VAO, and then we set the attribute in the first shader, all the attributes we are pushing in, and then finally in the display first we push the projection, and we use the program shader program 0, push the projection, and do the transformation for the light source, and then we do the transformation for the model, and we draw the model. And when it is cube is enabled, then we do the GL use program 1, and we transform the material as per the light source, and then we push the projection and model view light there, and then we draw it. This is the old code that is fixed function pipelining. So same thing we are using in shaders, and followed by we are using GLU perspective in the keyboard. We have local code that is transformation. It receives the transformation for various shapes. If I press tab, then it changes the shape, and if it is C, a capital C, it enable or disable the light cube, and that's it. Okay, so we have not changed anything. Okay, so we'll bring it again and we'll call up. Okay, so light source, will bring it near. I think this is not light source. So that we can bring that cube. If I bring too much near, then it will go away. It went away. Okay, so light source we can rotate. Okay, so light source we can rotate. And light is rotating. Okay, so we'll bring light source at the front, and then light source will kind of bring it far, and we'll just let it disappear, and then we'll bring the model near. This is shimmering because we are not using MIP mapping. Okay, so if I do kind of this is how it is rotating. Okay, in fixed coordinate we can do like this. Okay, so this is other side of Earth for us.